Hello, and welcome to today's daily Leetcode challenge. Today I'll be solving question 34, find first and last position of element in sorted array. If you want to see me struggle through the solution and ultimately come up with one, please watch the Python version. Here, I simply want to rewrite that logic in Rust to get a feel for how to work with types, how to work with borrowing, etc. So to sum it up quickly, search range, we need to find the left and the right bounds of some target within a sorted array in O log n complexity. So to do that, we use the binary search algorithm to find both left and right boundaries. However, there's a slight difference between finding the left and finding the right bound because of the nature of binary search. Binary search, if implemented based on how it's implemented, will either find the exact or a instance of a target, either the left or the right. And so basically this question is testing our ability to find both the left and the right, and finding if an instance either exists is trivial at that point. So what was the logic here? Well, we're going to have two functions. We're going to have find left, find right, and then essentially at the end, we're going to have a vector with that left and the right. That's it. So here, before we say let left equal b search left with some values, and let right equals b search right with some values. Cool. Okay, for the implementation, well, we need binary search, right? You need the left and the right bounds, target and nums. Target and nums, I don't want to pass directly to those functions, so we're going to use closures instead. I'm going to say b search left here is going to equal a closure that simply takes a mutable start as an I32 and a mutable end also as an I32. At the end, it's going to return to me another I32 integer, signed 32-bit integer, and let's go with implementation. Well, start is smaller than end. I'm going to want to find the mid. Mid is going to be equal to, so mid actually is going to be used as a usize. So here's the beginning of the problem with types, right? So you have this mid value that's actually calculated from the start and the end, but mid has to be usize. So how is that going to look? Start plus end divided by 2. That's going to be, let's see, is that going to be a float? As F32. And then we're going to call floor, because in Python you can simply divide. Well, actually, you could do that here too, right? You could do that here. You don't even need this. Both I32s divided by a 2 is just going to be equal to an int. And then if target is less than or equal to nums mid, by the way, as I already forgot, has to be a usize, because in Rust, indexes have to be of type usize. And if target is less than or equal to nums, I'm going to call end mid. And mid is an I32. Doing that conversion again. Else start is equal to mid as I32 plus 1. So that's my cutoff, right? And eventually, when I'm done with my loop, I'm saying that if start is less than nums len as I32 and nums start as U size, just means that it has to be is equal to target, then we're going to return start. That means that we found our leftmost index. Cool. Now for the right, similar approach, however slightly different. B search right is going to be a closure as well, because we don't want to have this complex borrowing of nums and target. I just want it to be accessible to me right away. Start as always, as previously I32, mut end is also assigned 32-bit integer, and the return value is also I32. Wow, so start is less than end, doing the loop. Let mid is equal, so here there's going to be a slight modification. I want to say that start plus end as an F32, because I want this to be float divided by 2.0. That also ensures that this is going to be a float. I'm going to now take the ceiling. The ceiling, as previously I mentioned, has to be done in order to sorry, am I doing this correct? Yes. Ceiling has to be taken to make sure that divisions that aren't whole round up to the higher values, so we don't have that situation where we go into an infinite for loop where start gets reassigned to mid over and over and over again. So while mid, and let's see, did I get all of this correct? So start plus end as F32 divided by a 2 ceiling. Yeah, I think this is good. If target is now smaller, is greater or equal to nums at mid, I'm going to reassign start to equaling mid as I32 as assigned 32 integer, else I'm going to say end is equal to mid minus 1 as I32. Cool. Same logic here, end is greater or equal to 0, just a bit reverse as I32, and nums of end as U size equals target, and then return end, else return -1. Awesome. At this point, I'm pretty sure that we're good with our setup of the two closures. We have nums accessible from within these values, and we never take ownership of it because we're simply accessing values on it. I want to now set the left bound and the right bound to these values. So B size left is going to be equal to, let's say, 0 and, 0 and nums len minus 1. And here, B search right is equal to this. Okay, let's see if this works. I hope that it does. If not, I hope this. Okay, I forgot to end this expression. And mismatch types. Len is not a U size, so I need an I32 here, and I need an I32 here as well. So far, pretty trivial errors. We are did I? Okay, so maybe I'm not allowed to subtract from this. I don't understand that. Am I not allowed to subtract from an unsigned size? Do I have to make this conversion here? Awesome. Cool. I think this is a fair solution. There's probably a better one that doesn't do, yeah, that uses some default function, but I don't want to do that. I want to do the hard work. Anyway, I like this. Clean and simple. The use of closures that don't take ownership of the variables that they use. So very, very good for like nested functions. Um, let's see, some work with usize and I32 conversions. So that's important because they're pretty commonly you have to deal with an index of some array. What else? Well, nothing else pretty much, right? The implementation is pretty simple and clean. Okay, well, thanks for watching. See you later. Bye.